Let's come up with a formula for the area of an ellipse. First, go ahead and identify which of these shapes is an ellipse, or click here to review. Right, so here's an ellipse. And remember that the longest segment going through its center is called the major axis, and the shortest segment going through the center is the minor axis. We'll be using these to find a formula for the area. And later on, we'll apply that formula to the ellipse in Washington, D.C. and figure out how many people can fit onto it at once. But first, suppose you have a circle and its radius is 3. What's the area of this circle? Click here if you'd like to review instead. Exactly. The area of a circle is pi times its radius squared. So for this circle, that's pi times 3 squared, or 9 pi. Now an ellipse is what you get when you stretch a circle. So what happens to the area of a circle when you stretch it out? To find out, let's look at a square, and suppose its sides have length 5. That means the area of this square is 5 times 5, or 25. Let's go ahead and stretch this square by a factor of 2, doubling its length. So now we have a rectangle whose height is still 5, but now its length is twice as long. It's 10. By stretching our square with area 25 and doubling its length, what's the area of this resulting rectangle? Right, so now the area is 50, or twice the area of the original square. In general, whenever you double the length of a shape, stretching it in some direction, you also double its area. And this applies to any shape, like this shape here. It has some length and height and an area of A. If we stretch it, doubling its length, this new shape has an area of 2A. So doubling the length doubles the area. So let's return to our circle with radius 3, and let's draw in another radius in the vertical direction. You already said the area of this circle is 9 pi. Let's go ahead and stretch this circle by a factor of 2 so we have an ellipse. This radius of 3 is now the semi-minor axis, and our other radius has become the semi-major axis. So after doubling the length of this circle, stretching it horizontally by a factor of 2, how long is this semi-major axis? Right, when we stretch this ellipse by a factor of 2, this length has doubled, making it 6. Now remember we said that doubling the length of a shape doubles its area. So we doubled the length of a circle with an area of 9 pi to get this ellipse. So then what's the area of this ellipse? Nicely done. So this area is 2 times 9 pi, or 18 pi. And notice that 18 just happens to be the product of this ellipse's semi-major and semi-minor axes. 6 times 3 equals 18. Very interesting. Let's stretch this ellipse again, but this time in the vertical direction, and let's stretch it by a factor of 3. So this length is still 6, but this purple length, which used to be 3, is now 9. Since the purple segment is now longer than the green one, this is technically the semi-major axis, and this is the semi-minor axis. So, we took an ellipse that had an area of 18 pi, and we've tripled its height. What do you think is the area of this ellipse? Brilliant! This ellipse has an area of 3 times 18 pi, or 54 pi. And once again, you'll notice that 54 equals the product of the semi-major and semi-minor axes. 9 times 6 equals 54. Try using this pattern to find the area of an ellipse with a semi-major axis of length 5 and a semi-minor axis of length 3. Right, this ellipse has an area of 15 pi, because 5 times 3 equals 15. So in general, the formula for the area of an ellipse is pi times A times B, where A is the length of the semi-major axis and B is the length of the semi-minor axis. Great, so consider an ellipse whose minor axis has length 4 and whose major axis has length 6. Try using this formula to find the area of this ellipse. And keep in mind that 6 and 4 are the entire major and minor axes, while this formula uses the semi-major and semi-minor axes. Excellent! If the major axis is 6, then the semi-major axis is 3. And if the minor axis is 4, then the semi-minor axis is 2. So the area of this ellipse is pi times 3 times 2, or 6 pi. So let's return to the ellipse in Washington, D.C., a grassy field located just south of the White House. Here are some facts about the ellipse. Its major axis runs east-west and is about 320 meters long, and its minor axis runs north-south and is about 270 meters long. Now, if each person occupies 1 square meter on the lawn, about how many people can fit onto the ellipse? You'll want to use this formula for the area of an ellipse in calculating your answer. Right, so about 70,000 people can fit onto the ellipse at one time. That's a lot of people. You've done some excellent work here. So remember, to find the area of any ellipse, you should multiply the semi-major and semi-minor axes and then multiply by pi. To get started, take a look at this shape here. It looks kind of like a pencil. Now, if you ever want to find the area of complicated shapes like this one, a great strategy is to divide it up into multiple shapes whose areas you can calculate. So let's draw some dividing lines, and now we've turned one big shape into 3 smaller shapes. What 3 shapes do we have here? If you're not sure, feel free to ask for a hint. Right, we have a semicircle, which is half a circle, a rectangle, and a triangle. Now let's include some measurements. Suppose this length is 4, this length is 8, and this length here is 3. Let's see if we can find the area of this overall shape. We'll start with the rectangle. Can you calculate its area? Exactly, the area of this rectangle is 4 times 8, or 32. Next, let's look at the triangle over here. This side of the rectangle has length 4, which means this side also has length 4. So our triangle has a base of 4 and a height of 3. So what's the triangle's area? Precisely, it's 1/2 base times height. So this triangle has an area of 6. Finally, let's look at the semicircle on the left, which has a diameter of 4. What's the area of this semicircle? Round your answer to at least 1 decimal place, and if you get stuck, click down here. Excellent work! This semicircle has radius 2, so the area of the entire circle would be pi times 2 squared. Because it's half a circle, that means its area is 1/2 times pi times 2 squared, which, as you found, is approximately 6.3. So, if the semicircle has an area of 6.3, the rectangle has an area of 32, and the triangle has an area of 6, what's the area of the entire shape? Well done! So you added these 3 smaller areas together to find the area of the entire region. 6.3 plus 32 plus 6 equals 44.3, the correct answer. Now sometimes, to find the area of a complicated shape, you need to subtract areas. Let's see an example. Suppose you have a circle with radius 10, and say you cut a diamond shape out of the circle. What's the area of this remaining shaded region? Your answer should have a pi in it somewhere. Here are a few more lines to help you out, and if you get stuck, just click over here. Very well done. So the area of the entire circle is 100 pi, and you subtracted the area of the diamond shape which was cut out, and this area is 200. So the area of the shaded region is, as you correctly found, 100 pi minus 200, and that equals about 114.16. So a good strategy for finding the area of complicated shapes is to break them up into smaller shapes, and then add or subtract them as needed.